Captain Peter Cutsey, South Korea. This is my briefing room. Loss of thrust on both engines. Scenario 2, part 1. We saw in scenario 1 an example of a windmill start being successful. The first officer followed the correct procedure. The engine start switches, flight, engine start levers cut off as soon as the EGT started to decrease. He moved the engine start levers to the idle dedent, and he did get a light on both engines within the 30-second limit. So that worked. And in that busy time, he then instated the electrical, the generators on all the buses. The number 1 generator and then number 2 generator control switch, and powered the buses, which enabled the captain to now reinstate the auto flight systems in proper order so that he could offload the workload and assist in what they're going to do next. Many things we haven't talked about here, and they're under the guise of airmanship. In this case, we're en route to wherever, let's just say for all intents purposes, on an airway to Dubai, and we were at high level. You've got people below you and around you. So it's important that you do actually fly the airplane, and you may not have all the warning systems that you had hoped that you have. So you have to be on the lookout for aircraft around you. And of course, get right into declaring, and this is the captain because the first officer is busy, declaring a mayday. And that's up to the captain. Remember, use judicial use of the VHF because you're draining the battery. Once you get electrical power established back on the buses, then draining the battery is not a concern. And remember, Captain, before you actually engage any autopilot, ensure that the stab trim cutout switches have been returned to normal. First of all, the handles in, stowed, and then return the stab trim cutout switches normal, then engage an autopilot, and then go left to right across the MCP and activate whatever mode you can and level off as soon as you can. And being off the airway is probably a good idea until you get organized and stable. And if you do get the APU running, which we did, leave it running, because you don't know why the engine's flamed out. Maybe you weren't going around thunderstorms. Maybe there wasn't any heavy water ingestion. Maybe the fuel was contaminated. Maybe you'll have the same problem again. So it would be wise that once you get the APU started, leave it running. Remember, the APU is good for electrical power use up to flight level 410. It is only good with the air supply up to 17,000 feet. Meaning, if you don't get a windmill start, you may certainly want to attempt a starter assist start. But you can't do that until you're down to 17,000, or in this area that we're flying, flight level 170. We're getting very close to the transition altitude, which is 150 for most airports there. But in any case, you've got to think about these things. So you may try to do a starter assist, but you can't because of the limitations not to use the APU bleed air above 17,000. So in scenario 1, we got a normal start. What we're going to do now today is we'll attempt a starter assist start just to see how that would work. And if in fact, would we have enough air generated from the APU above 17,000? So these are irregular circumstances, and you're going to try everything you can to start your engines. There's no way you're going to say, well, we can't get a windmill start, so we're going to stop there. Nonsense. Even though your N2 RPM may be greater than 11% for the NG and greater than 8.5% for the max. The max and the NG have the same procedure basically for the loss of thrust on both engines, with the exception that the engines are different. So the N2 minimum requirement for the max is 8.5% N2, whereas it's 11%. So you've seen that figure of 11%. I've got the QRH out for the NG, but be thinking max also at 8.5%. All right, so let's just go ahead and set up the scenario again, and then let's see if we can actually do a starter assist, pretending that we couldn't get a windmill start. All right, so as I give control to the captain, they will experience the loss of thrust on both engines. So, probably a good idea to maintain the heading, and we are descending, and the captain has got to descend at a speed of 200 and the captain's got to descend at 275 knots above flight level 270. So we'll target that. What we can do here, and we're increasing our speed. All right. Now remember, the captain is in manual flight, manual thrust, and also manual trim. So he's got the stab trim cut out, and he's got the trim handle out, and trim wheel handle out, and he is using manual trim, and he's attempting to reach 275 knots, which he's very close to that now, and above flight level 270, remembering to increase the speed to 300 knots below flight level 270. So we're going to go ahead and continue down into the lower levels, and then we'll simulate that we cannot get a windmill start, and we'll do a starter assist. At least we'll attempt the starter assist start. You should get a light with a minimum of 11% or 8.5 on the max N2 if there are no other underlying problems, if it was strictly a loss of thrust. Or whatever the reason was, is the reason why you may not, but more than likely you will. Now, as before in the last video, the first officer did attempt to start the APU and did get it online, and now can actually get the buses online by making the selection of the both APU gen switch control switches on. Now we've got electrics to the AC transfer buses. So let's say that we do have APU bleed air available. We'll go up and see how much. The first officer has actually got the APU online electrically. Let's go up and instate the pneumatics, even though we are above flight level, or above flight level 170, 17,000. This is important. You can't get a windmill start. You're going to have to try to get a starter assist start. So let's see how much air we have, and let's see whether or not we could use the APU, even though the restrictions are you shouldn't. We have to get engines going. APU bleed on and packs off. We maybe would have a chance at getting enough air. It doesn't look like we have enough air right now to do it, and that's why Boeing has stipulated 17,000. But let's see if we could get a start. We're going to have to try something. So the checklist for the starter assist is thrust levers closed. We'll go and do that. wing anti-ice off, pack switches, I've just turned them off, APU bleed air switch on, ignition selector both. So we'll go and do all of that, and then we'll try to start one engine first. And probably a good idea would be to start engine number 1 first, because it's closer in the plumbing as far as the APU bleed air being on the left side. So that may be a wise thing to start. So let's go ahead and try that. If we're going to try starting the number 1 engine first, I've closed the isolation valve to give us maximum air from the APU to the left engine. So here we are attempting, and we've got 23.9% N2, at least 11%. So let's give it a try. And the start valve is open. So we will move the engine start lever to the idle detent, see if we do get a start, in fact. Yes, we do. We've got a light. Now we are out of flight level 180, and our speed is quite high. But in any case, we are doing a starter assist, and we do have a light on number 1 engine. Number 1 engine, we have a light. So we tried something by thinking out of the box. It's not written in the QRH as such, but what are you going to do? If you don't get a windmill start, you're going to have to do a starter assist. So we tried it, and it worked. And my suggestion was to actually close the isolation valve to start engine number 1 first, because of the plumbing, and that makes sense logically, and it worked. We were close to flight level 170 or 17,000, and we didn't have 30 psi. However, we still got a light. So is it possible? You thought. Is it written in a book? No, it's not. Should we be trying things that's not written in the book? Well, if it means crashing and dying because it's not covered in a manual, enough said about that. So we use our heads. It's called airmanship. And it worked. Now we've got 1 engine going, we can fly the airplane. And then we can consider restarting the number 2 engine using the starter assist again, because we'll have extra air from the number 1 engine, and we can make sure that we move the isolation valve to auto or open if you're not sure. In any case, you can look at the pneumatic duct pressure, ensure that you have 30 psi before you attempt a start in the same manner as we attempted the start for engine number 1. So we succeeded in getting 1 engine started. So that will be the end of today's video. It's scenario 2, part 1. See you in scenario 2, part 2 in the next. Just before I go, we had a cabin altitude warning horn. Now, very possible. The 737 is a tight machine, but you could end up having the cabin climb. And when you're at flight level 370, your cabin is fairly high to start with on the cabin altitude schedule. So it wouldn't take long at 500 feet a minute to go from a cabin altitude of, let's say, 7,500 feet to 10,000. You're looking at 2,500 feet, and at 500 feet a minute, you're looking at 5 minutes. So it wouldn't be long. And by the way, we got that cabin altitude warning horn. So it would mean an extra procedure, of course, which is masks on. 100%, captain on oxygen, first officer on oxygen. Make sure you push the correct buttons on your communication panel so you can communicate. So all of that would be also in addition to a busy time on the flight deck. So you've got to use your head, and most important, the captain is flying the airplane. He can't get involved in what the first officer is doing. But thinking out of the box, if you can't get a windmill start on both engines, you're going to have to try a starter assist regardless. And I would recommend the way we did it, it was successful, to attempt to start engine number 1 by closing the isolation valve to give you more air from the APU. And then later on, when level and everything under control, and the autopilot engaged and everybody's informed, you can go ahead and start engine number 2 using a starter assist, but make sure you get the isolation valve in the auto position or open position if you're not sure on the operation of the isolation valve. Well, that's it for today's briefing, and we'll see you in the next scenario 2, part 2.